just wondering, have
Okay.
you folks thought about it?
Oh yeah, yeah. So I guess like one of our contributors like James brought up this like LWS thing a while ago. Yeah, and we will likely have a PR or proposal for like multi-node deployment in production stack, and LWS can be one of the options to do it. Like yeah, I can share the proposal once it's ready. Like one of our contributors, Eve from Lambda Labs, is likely to bring up the initial version of the PR of the proposal. Sorry, and I can share that with you once it's there, and feel free to bring up the LWS solution to that discussion too.
All right, cool. Yeah. Thanks. So if so are you saying like today you cannot do multi-node
Yeah, today we
inference?
cannot do multi-node inference. Yeah, like in production stack. Yeah, but that's one of the top priority like item on our roadmap. Yeah.
I see. Okay. And if you were to do multi-node inference, is I know that on the Ray is the default backend that is recommended on vLLM project. Uh, is it also what the production stack is going to use, or are there any alternatives that you're considering?
Yeah, so that's a good question. So right now, like, we'll probably have one like it's based on Kubernetes, I guess, like deploying Ray in Kubernetes. That's one of the options we're thinking of. Yeah, maybe maybe we're also like that's actually
No,
open for discussion to the community.
you,
Like,
you don't need you don't need Kubernetes to use Ray with vLLM. It's uh, as in like you just I can share the configs in a bit, but yeah, you just have to enable array as a array should be part of the vLLM image, and then you start the array service behind the scene, and then start vLLM. That's what is recommended in this LWS as well, LWS project as well.
oh, I
Uh, so hold on, let me find and share the config. But yeah. That's what is recommended. So we don't need Kubernetes as the full stack thing. That's what I meant. But yeah, I'll share the config in a bit. I'm just looking it up.
okay. No worries.
Yeah.
Thank you.
So I'll put it in the chat like this.
Okay.
If people don't have other questions, I have one more question.
Hey, yeah, are there other questions from the audience?
I have one question about the CRD autoscaler.
Mm-hmm.
So I also came across a this issue on the production stack repo. So the idea was like using Reserve as part of the production stack. So wondering if like using Reserve for CRD is also an option.
Mm, can you elaborate a bit about like do you mean like having a controller for the Ray part?
Just for say the auto scaling part, Reserve already provides a lot of um, like features beyond just like resource based auto scaling. So feel like if there is a lot of overlap, then maybe can see if like one solution is better or if really these two are just two distinct options.
I see. I didn't know that Ray can support this auto scaling. Yeah. Actually, like if possible, is it possible for you to have um a like proposal or PR for like using Ray as the auto scaler in production stack? Like you can like you can send me the proposal or PR, anything like you want to mention that in the community.
Yeah, sounds good. Yeah, I can also read the PR and also the usual link and see if there's a lot of like overlaps.
Okay. Okay. Great. Thank you.
So, okay, I think I can ask my question. So today, you know how like somebody who is deploying a model, they have to know what kind of tensor parallelism and pipeline parallelism they'll need. Like you have to know this upfront, right?
Mhm.
Is there a way where we can decide this afterwards? Like can this be dynamic, like without this being, hard coded? Is there a way to do that?
That's a good question. I guess, uh, I'm not sure. Like, do you mean like we can have do you mean like is there like a algorithm to determine or like is there
Or, I mean, if there are like, for example, today, like when I'm creating a pod, I have to know this upfront, and every time a new deployment come, I mean, and every pod that shows up needs those number of GPUs, be it on one node or be it on multiple nodes. The problem that I envision is this could lead to fragmentation, I guess, of GPUs, which is obviously an expensive resource. And as a consumer on any cloud provider, you're paying for the whole machine and not like individual GPUs. So I was wondering if there is a way to, deploy, for example, vLLM with these values generated on the fly, like some sort of a scheduler which sees, okay, like I need four GPUs, I have one on four different nodes, and then okay, I should do tensor parallelism as one and pipeline as four. Or if there is two and two, then I should do two, two. Or if there is three and one, like that. So that's what I was wondering if people know what is this recommended solution today. Do you babysit all these deployments, or is there a better auto scaling way to do it?
Uh, yeah, so I myself don't know that like the solution like this. Does anyone in the meeting knows any kind of solutions that might help with that? Okay, yeah, maybe I can yeah, we can leave this offline, we can figure it out. Um, yeah, maybe like we can you can reach out to Yihua, who's also on the on cache team. Like yeah, he may know some more details about configuring like different parallelism. Yeah. So let me leave a note. Uh,
Or if people have used Kuberay, have experience with it, does Kuberay support this kind of thing? Uh, it doesn't have to be. Uh, but my concern was only that, like, okay, since we have an operator, then I think this operator can make smart decisions on scheduling or assigning GPUs or placing the pods on certain nodes and things like that. Uh, yeah.
yeah. Yeah, we can have this discussion more like offline. Yeah.
And unrelated to the previous question, how is this project related with the AI bricks? Because I see like both these projects are the under the vLLM project umbrella. So,
Yeah,
and
yeah.
both of them are kind of creating a solution on top of Kubernetes. So I was wondering what's the overlap there?
Yeah. So there are some many differences between us with and Fabrics. So one thing is like our um like the design of our many interfaces in production stack is open to the whole community. And we want the whole community to design like those many interfaces, for example, like this multi-node inference together. And another thing, like we actually have benchmarked like AI bricks versus production stack last week, and we have a blog post here. I will paste the blog post here. Uh, sorry. Yeah, so feel free to check out. So basically, like production stack has a really good performance when you consider offloading KV cache to CPU. And it can be much more faster than those alternatives, including AI bricks. Yeah, and so basically, like our production stack right now have upstream support in vLLM. We have like Ion Cache uh, connectors PR merged already merged in vLLM. So basically, you can use the latest vLLM. So basically, Ion Cache is compatible with the latest vLLM. Yes, some these are some of the differences between us with AI bricks. Hope that answers your question.
Yeah, but like AI bricks could use LM cache to do this like distributed KV cache store, right? Like can achieve similar performances, isn't it? As in, LM cache is generic enough to be used by anybody.
Mm.
Is that the right understanding here?
Um, actually, I'm not sure. I guess it's not that easy to that
Hmm.
trivial to extend like to use cache code in directly in AI bricks. Yeah,
I see. Okay. Okay. So good.
yeah, maybe.
All I was saying is like, is there a fragmentation within the project, or like, is there a way to both the projects to work together? That's the only thing I was wondering.
Yeah, maybe you need like some pretty much like effort to pour like to try to use cache inside like AI bricks. Yeah.
I see.
Yeah. And also like I think the AI bricks like CPU offloading is written on top of like a very old version of vLLM. Like it's like point 0.6 point 0.2. And yeah, it might take a lot of effort if you want to port it to the newest vLLM version. Yeah, if that makes sense.
Right. Yeah.
Yeah.
Cool.
Okay, I think we are out of time now. Yeah, thanks everyone for coming to the community meeting today. And feel free to yeah, our next meeting will be at next Tuesday and at 8 a.m. PT. Yeah, and feel free to join if you are if you that time time zone works for you. Yeah. Okay, thank you everyone for coming.
Thank you.
Thank you.
Thank you.
Thanks, folks.